page 4, we have a proof here, and we're trying to prove that lines BC and AD are parallel, these two lines. We are told that AB is congruent to CD, that these two lines are congruent. We're also told that AB is parallel to CD. So these two lines are parallel. We're trying to prove that these two lines are as well. When we have parallel lines, I always like to extend them and then draw my transversal. I'll use the same color. So here is my interior of the parallel lines, and my transversal meet right here and right here. So those are alternate interior angles, which are congruent if these lines are parallel. And then this is a shared side. So you can see that the top triangle and the bottom triangle will be congruent by side, angle, side. And then we can go from there to prove that sides AD and BC are parallel. So let's start with the given. We have AB is congruent to CD, and AB is parallel to CD. That's given. And we can either talk about the shared side or the alternate interior angles. First, it doesn't matter because these are all blank. But let's say I said right here that AC is congruent to CA. Well, then that means the reason would have to be reflexive POC. Or what if I gave you the reason was alternate interior angles are congruent? That means the statement would have had to talk about my angles here. So it doesn't matter which one we use first. I'm going to go with AC is congruent to CA, and that is a reflexive property of congruence. And again, just like before, the reason why I switched them is in the top triangle, angle A has a marking of congruence for the angle, and in the bottom triangle, angle C has that marking. Then I'm going to talk about the angle. I'm going to say angle BAC is congruent to angle DCA. And that is because alternate interior angles are congruent. So now we can say the two triangles, triangles ABC and triangles CDA, are congruent by side, angle, side. Whoops. So triangle ABC is congruent to triangle DCA. ABC, DCA by side, angle, side. No, it's not triangle. I'm sorry, ABC. ABC is going to be CDA. Now, if the two triangles are congruent, that means the corresponding parts are congruent. That means this angle here and this angle here must be congruent. And if those two angles are congruent, let me just get my red pen. So if these two angles are congruent, and we extend this and then draw the transversal, okay, those two angles are congruent. Those are alternate interior angles when we're talking about sides BC and AD. And if those two are congruent, that means the lines must be parallel. So we're going to establish that angle DAC is congruent to angle BCA, and that is if congruent triangles, then corresponding parts are congruent. And because those angles are congruent, that means BC must be parallel to AD. And then if alt interior angles are congruent, then we have parallel lines. So that would be the reasoning for that. So remember, the reason why these two angles are congruent is not because the lines are parallel, it's because the corresponding parts of triangles are congruent. That then allows us to say that these two lines are parallel because those two angles are congruent, not the other way around. Alright, number 14, solve for x. All three of these angles need to add to 180. So x plus 3x plus 50 equals 180. 4x plus 50 equals 180. If we subtract 50 from both sides, we get 4x equals 130. And then we can type in the calculator 130 divided by 4. We get 32.5. And you can always double check that in the calculator. Do 32.5 times 3 plus 32.5 plus 50, and we get 180. Right, in this one, solve for x, we have the exterior angle theorem. These two angles will add up to that one. So it's going to be 52 plus 2x minus 8 equals 4x. So we can subtract 2x from both sides and combine 52 minus 8, and we will get 44 equals 2x. We divide both sides by 2. We get 22 equals x. And again, you can double check that. 22 times 2 minus 8 plus 52 is 88, and then 4 times 22 is also 88, so we're good to go. Alright, so classify the triangles. Remember, we can classify the triangles by the sides and angles. So I'm going to classify all these by the sides first. There are no markings at all anywhere, so this is a scalene triangle because there are no congruent sides. This one has two congruent sides, so this is isosceles. And this one has no congruent sides, so this is scalene as well. So scalene, no sides are congruent. Isosceles, two sides are congruent, and equilateral, all three sides are congruent. Then for angles, we can classify them by acute, right, or obtuse. Box means the right angle, so this is a right triangle. This is also a right triangle because the box. And this one has an obtuse angle, so this is an obtuse triangle. All right. So that will be the end of this video. I'll do one video for the last page in a bit.